Imagine a world where the impossible becomes routine, where technology doesn't just make life easier, it transforms the way we live, work, and connect. Today, we're diving into the technologies that will change the world forever, breakthroughs so powerful they will reshape industries and rewrite the rules of science. From AI that thinks faster than humans to energy solutions capable of powering entire nations sustainably, these innovations aren't just ideas, they are real. They are coming, and they will touch every part of our lives in ways most of us can't yet imagine. Let's explore. Synergistic Lift. Synergistic Lift is an innovative aviation technology that transforms how aircraft generate lift by integrating forces from wings, fuselage, and airflow to maximize efficiency and control. By distributing lift across multiple surfaces and optimizing airflow interactions, aircraft equipped with this system achieve longer range, improved fuel efficiency, and enhanced stability during all flight phases. The approach leverages advanced aerodynamic engineering and computational fluid dynamics to reduce drag, increase lift-to-drag ratios, and support higher payload capacities without sacrificing maneuverability. Synergistic Lift is applicable to both commercial airliners and military platforms, offering smarter, energy-efficient flight performance while expanding operational flexibility beyond conventional aircraft designs. George Benny Railplane. George Benny Railplane is a visionary hybrid transport concept developed in the 1920s and 1930s that sought to blend the speed of aviation with the stability of rail travel well before modern high-speed trains appeared. Conceived by Scottish engineer George Benny, this suspended overhead rail vehicle used propellers powered by onboard electric motors to thrust a streamlined carriage along a dedicated elevated track while guide rails below maintained stability and safety. Its design looked more like an airborne coach than a conventional train and aimed to separate fast passenger and parcel traffic from slower freight lines. Benny built a prototype test car roughly 52 feet long and weighing about 12,000 pounds, suspended from an elevated rail structure over a 426-foot demonstration line near Glasgow. With twin two-blade propellers driven by electric motors rated at about 60 continuous horsepower and bursts up to 240 horsepower, he projected cruising speeds as high as 120 miles per hour, potentially cutting travel times dramatically between major cities of the era. Each full-scale car was envisioned to carry up to 48 passengers, although the prototype carried fewer during demonstrations. Saildrone is a fully autonomous ocean surface vehicle powered primarily by wind and solar energy that sails the world's oceans, collecting high-resolution atmospheric and oceanographic data without human intervention for extended periods. Its fleet of uncrewed surface vehicles operates continuously for months, delivering persistent environmental intelligence and robust situational awareness for science, maritime security, climate research, and defense missions. In its Explorer class, the Saildrone vessel is about 7 meters long, with a wing height near 5 meters and a draft around 2 meters. Powered by a patented wind wing sail, coupled with solar panels that energize onboard systems, it can cruise at about 1 to 3 knots while gathering data and remain at sea for more than 12 months without resupply, thanks to renewable propulsion and autonomous station-keeping routines. Saildrone's sensor suite includes precision meteorological and oceanographic instruments that measure wind speed and direction, air and sea temperatures, barometric pressure, humidity, salinity, dissolved oxygen, chlorophyll, pH, and sea surface currents. Honda EV Outlier is a forward-looking electric concept motorcycle unveiled at the 2025 Japan Mobility Show that explores what future zero-emission two-wheeled mobility might look like. Defined by Honda's precision of intrinsic design philosophy, the Outlier's sculpted body and futuristic silhouette emphasize smooth, flowing surfaces and a dramatic low riding posture that expresses its electric character. Instead of a traditional chain or belt drive, this concept places dual electric motors directly in the front and rear wheels to centralize mass and enable torque distribution between both wheels for dynamic response and handling. Unique engineering choices such as a double wishbone front arrangement and a low-mounted monoshock rear linkage further differentiate its mechanics from conventional motorcycles, supporting a riding feel Honda describes as gliding and ecstasy, translating to quiet, immediate acceleration and seamless power delivery with a low center of gravity. A wide digital cockpit displays ride data including speed, battery status, and torque distribution in real time. And disc brakes front and rear provide dependable stopping power. Radian 1. Radian 1 is an advanced single-stage orbit spaceplane under development by American aerospace company Radian Aerospace, engineered to take off and land like a conventional aircraft and reach orbit in a continuous flight that eliminates expendable rocket stages. It is designed to transform access to low Earth orbit by combining horizontal runway operations with full reusability and rapid turnaround between missions. Radian 1 measures about 120 feet in length with an 85-foot wingspan, and its wing design leverages aerodynamic lift in ascent while reducing thrust demands compared with traditional vertical rockets. The spaceplane is engineered to launch from a 2-mile-long rocket-powered rail sled that accelerates the vehicle to high speed on a runway before the onboard rocket engines assume power for orbital insertion. The vehicle's architecture supports 2 to 5 crew members, or an equivalent combination of personnel and cargo to orbit. It can carry up to 2,270 pounds of cargo to low Earth orbit and return up to 4,540 pounds of downmass, providing exceptional flexibility for resupply, scientific research, in space manufacturing, and other mission types. The internal payload bay offers approximately 93 cubic meters of usable volume for equipment and experiments. DJI Zenmuse L3 is a professional high-accuracy aerial LiDAR and RGB mapping payload designed to push surveying and geospatial data capture into a new class of precision and efficiency. It combines a long-range 1535nm LiDAR sensor capable of detecting up to 950 meters distance on surfaces with 10% reflectivity with dual 100-megapixel Micro Four 3 RGB cameras that enhance point clouds with detailed color imagery and orthophotos. This pairing enables comprehensive mapping workflows that deliver dense, high-resolution 3D models, digital orthophoto maps, and terrain reconstructions in a single flight. Built for enterprise applications when mounted on a compatible DJI Matrix 400 drone, the L3 supports adjustable laser pulse frequencies from 100 kHz to 2 MHz and up to 16 returns per pulse, giving operators flexibility to optimize for ground penetration and return density in dense vegetation or urban complexity. Its ranging repeatability is under 5 mm, and absolute accuracy can be around 10 mm, delivering survey-grade precision. Typical vertical accuracy is better than 3 cm at 120 meters altitude and better than 5 cm at 300 meters altitude, with daily mapping coverage reaching up to 100 square kilometers under efficient flight profiles. Even G2 and R1 Exosuits are advanced wearable robotics engineered to enhance human mobility, strength, and endurance. Using AI-powered motion tracking and lightweight, flexible materials, these suits provide full body support for walking, lifting, or carrying heavy loads while reducing fatigue. The G2 is designed for industrial and labor-intensive tasks, delivering sustained support for repetitive work, while the R1 is optimized for tactical and outdoor use, ensuring durability and performance in challenging environments. Both exosuits respond instantly to the wearer's movements, amplifying natural biomechanics and enabling effortless, energy-efficient motion. G2 weighs approximately 35 pounds, and the R1 weighs around 38 pounds. Both can assist with lifting up to 110 pounds and offer battery life between 6 and 8 hours depending on workload. Actuators and sensors respond in milliseconds to user motion, and modular components allow quick maintenance or adjustments. The suits are rated for operation in temperatures from 15 to 110 degrees Fahrenheit and are built to handle dust, light moisture, and uneven terrain, making them reliable for extended real-world use. Samsung Galaxy XR. Samsung Galaxy XR is a cutting-edge extended reality headset that blends virtual reality, augmented reality, and mixed reality into a single immersive computing experience. Built around the Android XR operating system with deep integration of Google's Gemini artificial intelligence, the Galaxy XR delivers expansive 4K micro OLED visuals with about 27 million total pixels and a 109-degree horizontal field of view, letting games, movies, productivity applications, and spatial content feel vivid and real. Qualcomm's Snapdragon XR2 Plus Gen 2 processor, paired with 16GB of memory and 256GB of storage, fuels high-fidelity tracking, gesture recognition, eye tracking, and responsive AI assistance that adapts to your environment and intent in real time. And multiple world-facing cameras plus advanced depth sensing, hand and eye tracking bring intuitive control through natural movement, voice, and gaze, while spatial audio and lightweight ergonomic design support comfort during extended use. Headset weight is about 1.20 pounds, with an external battery pack that powers roughly 2 hours of general usage, or 2.5 hours of video playback without interruption. Peugeot Polygon. Peugeot Polygon is a striking all-electric vision of urban mobility, showcasing the next generation of Peugeot design and technology with bold geometric lines, smart systems, and sustainable materials. Laid out in a compact footprint under 4 meters long, its sharply faceted exterior emphasizes horizontal micro-LED lighting and a feline stance that signals the brand's future aesthetic direction. Its 2 butterfly-style doors and glass canopy create a dramatic silhouette while keeping the vehicle light and efficient. Inside, the Polygon abandons the traditional steering wheel and dashboard in favor of Peugeot's groundbreaking hypersquare control system paired with steer-by-wire technology. This fully electronic steering system removes the mechanical link between driver input and wheel movement, was enabling exceptional agility at low speeds with minimal control rotation and precise responsiveness at higher speeds. The expansive digital iCockpit experience projects key information directly onto the windshield with a large reflective micro-LED display and a dedicated micro-LED panel on the C-pillar surface's battery charge status without entering the vehicle. As we wrap up, remember that accuracy isn't just about specs on paper, it's about engineering, design, and the perfect synergy of every component working together. The rifles we've explored set the benchmark for what's possible when craftsmanship meets performance. If precision, reliability, and sheer engineering excellence excite you, these platforms redefine the standards of shooting. If you enjoyed this breakdown, make sure to like the video, share it with fellow shooters, subscribe for more precision-focused content, and drop a comment telling us which rifle impressed you the most.